Hi my friends. Today we discuss about sheet metal parts. This is a sheet metal part. You can see some specific elements here which are repeated, like this corner for cutting to have a good behavior of the material, the sheet metal, when the technological process creates the part. Let's see how to create this part by using a specific template in Inventor. We must respect all the data in this drawing. We start by invoking the sheet metal template instead of standard template. They have both the same extension, so when you finish this and create a part, you don't know from the beginning if it is a sheet metal or a solid part. Let's start. The first thing we have to do is to apply sheet metal defaults. Sheet metal defaults because the part has 2 millimeters. You see here, the sheet metal is of 2 millimeters and not 0.5, which is by default in the template. We can change in place the thickness 2 millimeters, or we'll go to the now very known by you style and standard editor. You see, this is the object sheet metal rule, and we use the default millimeters variant. We see here many things. We'll discuss about them, and the thickness is one of them. We can put here 2 millimeters, save and close, and when we go here we can activate use thickness from rule, which means from the standard editor, and it is the same 2 millimeters thick. Okay, now we start by creating a sketch in the plane XY. Remember XY. And now we look to the drawing. The drawing has a profile here, which is important, and we have to use its dimensions, not to invent some other dimensions. You know what I said in the first tutorials. So we keep in our mind 8, 90 degrees, R18, R2 on both direction, and so on. We create a circle with a radius 18, and then align so and so, which must be here perpendicular and which has to be coincident with this point, coincident this with the point. Then we project as center line the axis y. Nothing else. So this is the center line, y. To use mirror, selecting this, selecting the mirroring line, mirror line, and apply. Now we can use trim to cut unnecessary arcs of the circle. We place here the dimension 90 degrees and we are sure of the symmetry. We add the dimension aligned, not so, but so, of 8 millimeters, and you see here the dimension 98 from this point to this point, the contour which goes to the center. Yes, this is the contour, not the offset one. Oh, and this is why we have to put here 20. Excuse me. 18 plus 2. Because we have to consider the thickness of the part. Then this is I want to be very clear. This is 18 and we create this contour, the down one. Yes, and now we apply here the radius of 2 and here the radius 2 plus 2. Fillet 2 is by default here and here, and 4 2 plus 2 from the thickness here and here. And now we can place the dimension from the ends from end to end of 98. Fully constrained sketch. Okay, and now I want to make something new for you. I don't like the sketch to be in this plane. I want it to be in this plane. This is why I asked you to remember that we create a sketch in the XY plane. Now I want to change it in YZ plane. Escape now, and the procedure is to right click on the sketch and to apply redefine. Redefine asks us for another plane and we select this plane instead of the other. The sketch is here. You can see a small mark here which confirms that the sketch is fully constrained. You have to be sure of this, that this point could be in another place sometime. Okay, now you have to see here another ribbon than at the common parts. One tool here is this one. We don't have access to this one because the part is at the beginning. Contour flange asks for a profile. This is the profile. We have to look very careful here because we want the this contour to be down, not up. This is why we change the offset direction here. Yes, I also ask for the dimension 70. This is that dimension 70, this one, because we want to create the a part with 70 millimeters length. We place here 70 and we choose not this, but this variant to be symmetrical about the plane of the sketch. This is not enough. We have to see. Okay. And this is the first presentation of our part. The next step is to create these flanges. Yes, 1, 2, 3, 4. To do this, now I have access to the specific tool, and the first moment is to show which is the edge we use for that flange. You have to look along to see options. We use this option because we want to measure from the radius, from the external radius, and this one because we want to be outside the part, not like say here or here, to be tangent to the face, the side face here. We want this solution. Okay, good. Now we have to define the height of this flange, and the height is to be obtained from here. You see 12 plus 10. This is the height. Yes. So we go back and we write here 12 plus 10. It's not enough. We go here, we ask for width. We'll precise the width. The width is not the whole edge, but a part of it. Now we have to, this centered? No, I don't think so. The situation is presented here. This is why I select offset. I select from where we measure this offset. We measure it from here is the dimension 23.5, which is the offset is 23.5 minus 10, the radius. Good. 23 from where? From this face. And the other direction, 23.5 minus 10. The flange itself has the width of 2 multiplied 10. Yes, we use the dimensions in the drawing. What if this is the radius 8.795? You don't calculate in your mind this. Another thing is that this will stay there and you will know where is the mistake. Is 23.5 in the drawing? Yes, it is. Is it 10 in the drawing? Yes, it is. If the drawing is wrong, you are wrong, but you respect the drawing. Excuse me for these details, but they are important. Now all is defined. Okay, you can see here the new flange. What we don't see is this cutting, and this is missing. To change this thing, we have to go to the Style and Standard Editor library and to go to the bend and to look here. Minimum remnant is thickness multiplied by 2. We multiply it by 1. When to apply this relief? To apply when this is smaller than the rule we want. And now look here, save and close, and now this is also present. The dimension here was changed to apply this cutting. We want to have this cutting. The drawing is with double cutting on both sides of the flange. Yes, this is why. Good. Now we apply. Now we have to apply corner round to this corner and this corner with the radius of 10. We know this. Yes. Now we apply a hole on this face with this center of 5 millimeters diameter. Okay. Is it real? Yes. 2 holes of 5 millimeters. Now I prefer to create these holes and then to apply double mirror on both directions to have all we want in a quarter of the part. You see here, the part is perfectly, this is the flat pattern we'll discuss about, is perfectly symmetrical by 2 directions. Hole on this face at a distance measured from here 14 and from here 15. Where are these dimensions comes from? 14 and 15. Yes, 15 is on the side. 15 is from the side. Okay. Now we have the corner, and we use mirror 2 times. Mirror of what? Mirror of our last flange, corner round, hole, and another hole. All these 4 features, 1, 2, 3, 4, must be mirrored using one of these 2 planes. Let's start with this one. No, this one. You see here where are they placed. Okay, and now once again I tap the space key and I select 1, 2, 3, 4 and the previous mirror to be mirrored about this plane. Okay, very good, symmetrical on both directions. Now I have to create this cut. Yes, a rectangle with 2 arcs instead of lines, and this dimension 13.5, 15 like the hole, 15, and radius of 7.5 and 10.5. We'll respect them very exactly. The plane where we create this is the plane, this plane. I click on it and I click on sketch. Now I draw a rectangle with the ends missing because we add arcs instead. 1 arc from here to here and with a radius of 7.5, and the other one here with a radius equal this with this. So both of them are 75 radius. 10.5 is this dimension, and this is X, this is Z. The proper position is this one, because this is horizontal and this is vertical. We want to place on the same horizontal these lines, not on the same vertical. We need to place a construction line from midpoint to the midpoint and to place the dimension from this new line to the end of 15, like in the drawing. We still need to place 2 dimensions. Let's go back here. 13.5 is one of them. 13 from here to here, 13.5. a dimension is missing. Let's place auto dimension, apply, and we see a value here. I know what it remove, and look here, I can move this so and so. 10.5. These two must be symmetrical about the axis. I prefer to add equal always in such situations. Yes, equal is wonderful. We don't have to add axis and so on. Finish sketch. Now is fully constrained. The tool to create this cutting is cut. You are right, cut. Let's go to the drawing, to the part, and use cut. Selected. The direction for cutting, the profile is selected, the distance is all, and the direction is to the part. OK. Now you can see the cutting, the cutted part. Now mirror, we use again mirror about the plane, this plane. OK. F6, and to select the material. The material is steel carbon, and I want to be polished, steel polished. This is the part. Properties for you, and update to have the particular data of this part. The last thing we can do, having this model, is to ask for the flat pattern. You see here the flat pattern, which is created by Inventor. Create flat pattern, and this is the flat pattern. You can place it in your drawing like I did here, and I'll show you how to do. But now you see here selected pattern, or double click here to see the folded model. You can do this by using this tool. Go to flat pattern and go to the model, but only after you created the flat pattern. Now if you want to place all in the drawing to be like here, you know what you do. You use our template for drawing, or any other you create for your own using. Then you place first view, which can be the one in our drawing, placed say here, and the orthogonal projection below. OK. Another one auxiliary, starting from this view from this direction, to be placed here. If you change the aspect with hidden lines and with tangent edges. Okay, you have all of them same. I don't see hidden lines. Now we'll see. Okay, now I want to place here a projection like this one. So I create a new base projection using not this but custom view, which is this one. Placed here as a picture. Okay, and what about the flat pattern? This is base. I have to select a document because we have here sheet metal and sheet metal after the tutorial. I'll choose this one, sheet metal after, and I select not folded model but flat pattern. There's not room for it, so I choose 1 to 2 the scale. Okay, now you know what is this. That's all for today. I'll come back with other details about creating sheet metal part in the next tutorial. For now, I wish you a nice time and bye bye.